something I learned really quickly about Josh is he is one of the not, if not the fastest engineer that I've ever met in my life. And that kind of goes both ways. You know, sometimes I'd look back and finish building his car. Other days I'd look and he'd be like, oh, I've lost a component. And you know, one day I remember very carefully, right? So he's like, oh, I lost my component. I'm searching on the ground with him. And like the light bulb goes off and his eyes brighten. I'm like, oh, he probably remembered where it was. So he goes over to the trash can and starts digging. Oh, I accidentally threw it away. All that to say, Josh is, you know, a really whimsical guy, and his ideas are not only great, but you know, have a very cool factor to it, as I think he'll present in a second. And I don't know, I genuinely think he might have a career in defense later. But yeah, I think he's worked really hard on this project. I'm really excited for you guys to see all the modifications he's made. That's it for it.
Hi, my name is Josh, and I go to Lee High School. And the project that I'll be talking today is called the Gesture Control Robot. The reason I chose to do this project was because I was interested in learning how your hand gestures and movements will control machines movement. So, and throughout this project, I was able to learn exactly how it worked. So essentially, whenever you tilt your hand a certain way, like forwards, backwards, right, and left, then the robot like moves and rotates correspondingly. But as you can see, there's more than just the robot. I've also mounted on top a robotic arm, which allows the project to be able to pick up items and move around instead of just being an RC car that drives around mindlessly. And now I'll begin my live demonstration. So. As you can see, whenever it's on the controller certain way, like forwards, backwards, forwards, right, and left, it can rotate and also move forward, backwards in the same direction. And the way that works is through an accelerometer. The accelerometer is on the controller, and it's basically it's a sensor that detects which direction something accelerates in, and that direction is put into XYZ coordinate format. And that XYZ data is sent over to a microcontroller on the board, which then sends the information to an HDF5. The HDF5 on the controller then sends it to another HDF5 on the Gesture Control Robot, which then it takes the information and translates the XYZ data into the simple commands such as forwards, backwards, right, and left. Then the motors on the robot can control and take it to move. And now moving on to the robotic arm, as you can see, I can rotate the face, right and left, and also I can move up and down from there, as well as the neck, and open and close the claw. And the way this works is similar to the Gesture Control Robot's movement, but instead of having the accelerometer send the data over, the joystick is sending X, Y data to the robotic arm. And since my code can't handle two commands at once, I have thresholds set, so if the X and Y data is within a certain threshold, for example, if I move my joystick this way or left, and the claw opens, which is because the data is 1000, 0, so X 1000, Y 0. So I have set if the X is greater than 1000, then the claw will open, and if it's less than 10, then it'll close. And although this project, now it's the documentation. Although this project works great now, it didn't come without its challenges. So the two biggest challenges that I faced here with Stamp were bad Bluetooth connections and also mismeasurements. So starting off with mismeasurements, when I was creating the 3D pieces for my circuit boards to test with the Gesture Control Robot, I mismeasured the screws multiple times, which led to me wasting a couple of days on just sitting and waiting for the computer parts. Instead of moving on to my modifications that I could have done even more modifications, but I've done now. And another challenges I face, which I think is the biggest, is the Bluetooth connection. And the reason that this is the biggest problem or biggest challenge was because it seemed like whenever I fixed the problem, a new problem would pop up. And like for example, one time I mixed up wires that for the whole day, like I thought it was the code, but it turned out it wasn't. It's just the hardware. And then the other time, everything was right. The wires were right, the codes were right, but then the HDL files themselves were fried. So I got new ones, and eventually it worked. But something I took away from both of those challenges was that I should measure twice and like act once. And also, when I'm debugging things, I should think through chunks instead of like taking on one thing at once. With the problem. And now that Bootstrap's over, I realized that I learned a lot of new things, such as learning how to code using Arduino, soldering, and also a lot of other things, like my circuit boards and also my components in my project. So I think I'll take all of whatever I learned at Bootstrap into my future engineering career, such as future projects that I may take on, and also my school's engineering program. Any questions?
Your project looks really cool, right? Like you got like it locked in on top of that. Was there any inspiration behind how to do it?
To be honest, no. I just thought of it like because I already had the case surrounding the original gesture control robot, so I decided to add a mount on top of it so I could easily attach it without having to add extra like screws or something like that.
Which part was harder, the gesture-controlled car or the joystick-controlled car?
Definitely the gesture control robot part because I had to figure out like how to get the data from the accelerometer to the motors for the first time. Because when I was creating the robotic arm, I already experienced from the gesture control robot, so I knew what I was doing. But for the first time, it was way harder to work on.
Did you have any issues with the accelerometer at all, like specifically?
Nothing I didn't.
Oh, really?
How many Bluetooth connections did you end up having to make? Like, how many modules did you use?
So, I used like I tested 6, but I really only should need 2, but I tested 6 and I used 4 of them because it turned out 2 of them were faulty, like I said, in the challenges, and I used 4 because I originally had separate controllers for these, but once I combined them, I realized that I could have just had 1 for each, but it was really too late for that. I didn't have enough time, so.